Hello guys, in this video I'm going to show you how to solve search in Bitonic array problem. So given a Bitonic array, find if a given key is present in it. An array is considered Bitonic if it is monotonically increasing and then monotonically decreasing. Monotonically increasing or decreasing means that for any key I in the array, the number at index I is different than the number at index I plus 1, right? So our goal or task is to write functions to return the index of the key. If the key is not present, return -1, right? So here is a given input. It is a Bitonic array, right? You can see it from 1 to 8, 1, 3, 8. It is monotonically increasing, and from 8 to 3, 8, 4, 3, it is monotonically decreasing, right? So we need to find number 4 in this Bitonic array, and because if it is a, let's say if it is a normal array, let's say a sorted array in increasing order, then we could use binary search, right? But because it has both increasing and decreasing parts, so we really don't know where is the keys located in the array, right? So let's say here is a increasing part, right? It's from 1 to 8. So we're looking for number 4. So number 4 could be in this range, but also it can be in this range in the decreasing part, 8 to 3, right? So we have to probably check both parts, right? But another problem is that we don't know where's the boundary that where's the boundary between increasing and decreasing part, right? So for example, in this case it is 8, the boundary between increasing part here and decreasing part, and also it is the largest number in this array, right? So probably we need to somehow find the boundary or the maximum number of Bitonic array first. And if we know the boundary, then we could apply the binary search, normal binary search for increasing portion and decreasing portions separately. So how can I find, can we find the maximum number or the boundary between increasing and decreasing portions? In this case it is 8, right? So because it is uh, because our array has increasing part and decreasing part, but we really don't know where's the boundary. Can we can we uh, can we apply the binary search here, but uh, with some modifications? Let's say we divide. Let's say we find the middle first, right? The middle number in this case is 8. Uh, and in this case, we want to know that if 8 is in the increasing part or in the decreasing part. Um, we could compare 8 with the number right next to it, to the right, which is 4, and 8 is greater than 4, so it means the portions starting from 8 and all the way to the right is the decreasing portion. Mm, so that means we could narrow down the portions that contain the maximum, right? Because it is decreasing from 8 all the way to the right, so the maximum must be from 8 and all the way to the left, right? The increasing part could must be on the left, right? Here. So here could, then we continue searching from here using the same logic. Okay, here is a new search space. We have 3 numbers, the middle one is 3. Again, we compare with the, here's the middle. We compare with the number right next to 3, which is 8 in this case. So 3 is less than 8, so So it means uh, so it means 8 from number 8 all the way to the left is the increasing part, right? So we further narrow down the search space. It should be 8, right? At the end, it should be 8. Uh, okay, the middle one is 3, right? We compare it with 8. 3 is less than 8, so 3 and 8 is on the increasing portions um, of our array. So because we are looking for the maximum number, so we're looking for the maximum number. So again, we narrow down the search space to uh, to the right of number 3 here, which is 8, right? So here probably we exceed the the, the searching because our search space has only one number, so it should be the largest number, and also the boundary between increasing part and decreasing part. Then after we have found the maximum number, we could apply binary search to increasing part and decreasing part separately, right? Uh, let's try another example. In this guy, the maximum number is also the middle one, right? But let's say we have another example, something like 1, 2, 4, 5, 7, 8, and 9, then 6 and 3. The index will be 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the middle number, the first step is to find the maximum. It could be, it is clear that the maximum number is 9 here, but we don't know it yet. So 9 is number we need to find from this Bitonic array, right? So okay, we first find the middle number. In this case, at index 4, which is number 7. Let's say here's the left, here's the right, and here's the middle. Okay, we first compare the middle number with the number right next to it, to the right, which is 8. So 7 is less than 8. So it means 7, 8 is in increasing portions, right? Or from 8 all the way to the left is increasing portions. So it means the maximum number must be 8, must be 8 or all the way to the right of 8. So we narrow down the search space. So left now is 8 and right stay the same. And after that, uh, the middle will be the new middle will be 9. Okay. Again, we compare middle with the number right next to it to the right, which is 6. 9 is greater than 6. So it means 9, 6 is a decreasing part, is in decreasing part. So it means the increasing part is to the left, right? And the maximum number could be from middle and all the way to the left. So we reassign the right. So here will be now our new search space. So here with the right, new right, and okay, and here will be the new middle. Middle will be equal to left. Okay, again compare left middle with the number right next to it, which is 9. So 8 is less than 9. So here is a increasing part. So it means the maximum should be to the right middle. So the new lab will be middle plus 1, which is now left and right is at number 9, which also the maximum number. So when left is equal to right, it means we have found the boundary or the maximum number, right? So we can exit the searching, and we could apply here's the increasing part, and from 9 and all the way to the right is a decreasing part. Then we can apply the binary search for this part, these portions, and another search for these portions. Okay, let's dive in coding now. Okay, so the first thing we need to do here is to find the maximum, which is also the boundary between increasing and decreasing portions. Okay, in order to solve, we uh, we will do the binary search with modifications. In this case, we need lab is 0, right? The first index, and right is the last index, which is array.length -1. And as long as lab is less than right, we want to keep searching. And when lab equal to right, it means the max index is, let's say, the lab. Okay. Okay, from here I could apply the binary search. Uh, I could apply the binary search here. We want to search from 0 to max index, and also I will search to the right. I search for the key, right? We need the key. Here the start index, here the end index. Here's a range, right? We want to search in, and the second portion will be max index all the way to the right, which is array.length -1. And this must be uh, indications whether it is a increasing or decreasing array, right? So let's say if it is increasing, I will passing through here. If it is decreasing, passing false. Mm. Let's resolve, and if it is found, return, right, resolve. If it is different than -1, then I'm gonna return result. Otherwise, I need to search for the second half, the second portions. We need to write another functions to do binary search, passing in array, the key, uh, from index, the range to index, and is increasing. Okay, let's do write the logics for finding max first. So for finding max, we first find the middle index, which is will be left plus right minus left divided by 2 right This will calculate the middle index. Okay, after that I will compare the array at middle with the number right next to it on the right, which is array middle plus 1. So if the middle number at middle is less than number at middle plus 1, it means the maximum number we can narrow down uh, the search space of maximum number from middle from index middle plus 1 all the way to the right. It will be, so I will reassign the left equal to middle plus 1 and the right will stay the same. But if it is not the case here, it means middle is greater than middle plus 1, right? So it means we could narrow down the search space for maximum number to the left, right? So it inclusively, which means the current number could also be the maximum. So right. So it means the left boundaries will stay the same, but we'll reassign the right. The right will be the middle, because the middle could be the maximum. Okay, we exit when left equal to right. It means left and right is the index of maximum numbers. I reassign to another variable here. Start the binary search separately for two portions. Okay, the last thing to do is to write logics for binary search. Right, same here. I need left and right, but left here will be from index and right here will be to index. So as long as left is less than or equal to right, then I want the middle. I need to calculate the middle index. So if the key is equal to number at middle, then return key. No, return middle. We return the index. If it is not the case, it means it could be on the left or on the right middle. So we need to determine. But because here it could be a increasing order or decreasing order, right? So this will determine what kind of this will determine if the array is sorted in increasing or decreasing order. So if in increasing order, else it is decreasing, and depending on whether it is increasing or decreasing, we could mm, find whether keys is on the left or on the right, right? So if it is increasing array, and so we could compare the key with array at middle index, the number of the middle index. Key is greater than the middle one, and it is increasing order, so it means the key will be on the right at middle. So I'll reassign left to middle plus one. Else means key is less than the number of middle index. So I'll reassign the right to middle minus one. Another case is it is sorted in decreasing order. So if key is greater than array at middle index, so because it's decreasing and key is greater than the number at middle, so key should be to the left. So it means I reassign right to middle minus one. Left stay the same. Else the key is less than the middle, so to the right. So I will reassign the left equal to middle plus one. Right is the same. If we exit without returning here, mean I cannot find the key inside this portion, so return minus one. Okay, let's run the test. Just 11 and 7. Okay, it works. Let's double check it. Okay, awesome. So it works. So that is it for search in Bitonic array. Thanks for watching. See you on the next video.